End-to-end autonomous driving has pivoted to vision-language action models, but they're still bottlenecked by imitation learning. These models train open-loop against expert trajectories, causing severe distribution shift the moment you switch to closed-loop inference. Errors compound and the policy degrades. To close this gap, Qualcomm AI research introduced CLEAR, a system that scales closed-loop reinforcement learning for end-to-end driving. Formally, this is a partially observable Markov decision process, where the policy maps multi-camera observations, ego speed, and navigation prompts to vehicle actions. Instead of retraining a massive VLA from scratch, CLEAR freezes the pretrained vision and language backbones and learns a residual waypoint policy. Here's the technical breakdown. The frozen VLA outputs a base path and speed waypoints. CLEAR defines fixed longitudinal anchors in the ego frame. At each anchor, it interpolates the base lateral offset and estimates a target speed from the temporal waypoints. The RL policy, optimized with Proximal Policy Optimization, conditions on the frozen driving features and this base plan to sample bounded residual corrections for lateral offset and speed. These residuals are clipped, added to the prior, and passed to a deterministic controller. This preserves pretrained geometric knowledge while enabling closed-loop correction. The reward function is based on discounted route completion, with soft penalties for minor deviations and hard penalties for collisions or traffic violations. But RL is data-hungry, and scaling vision policies usually crashes under GPU memory contention. CARLA's rendering stack alone consumes 6 GB per instance, starving the VLA learner. CLEAR solves this with a heterogeneous pipeline. Simulators run on older Tesla VS or consumer GPUs, while the PPO learner runs on H100 clusters. They communicate via SSH tunnels. This decouples compute, eliminates resource contention, and stabilizes training. The result? 60 parallel environments, 100 million samples, and a 16,000 total batch size for PPO updates. Ablations confirm that direct low-level control fails to leverage the pretrained prior, while scaling the mini-batch to 4096 is critical for convergence. On CARLA's longest 6v2 and bench-to-drive benchmarks, CLEAR shatters previous success rates and route completion metrics, while holding competitive zero-shot performance on nuScenes. It's a clean architectural fix that finally bridges the open-loop to closed-loop gap for VLA driving policies.